Right now, you probably have GPS on your phone. You use it to find a restaurant 3 blocks away. You've maybe used it to navigate a city you've visited a dozen times, and you probably don't think about any of that. You just open the app, follow the arrow, and arrive. But here's what's strange about that. For the overwhelming majority of human history, there was no arrow, no satellite, no map, no compass. Just you, the ground beneath your feet, and a sky full of stars. And somehow people crossed oceans, moved through mountain ranges, and found their way back home from places they'd never been. Not occasionally, consistently, across tens of thousands of years, on every continent, in every climate. The question is, how? And when you actually look at the answer, it changes how you think about memory, perception, and what the human brain was quietly built to do. Let's start with the most basic version of the problem. You're an early human. Maybe 100,000 years ago in Africa, you've been walking for 2 days following animal tracks. The terrain looks the same in every direction. There's no trail. Nothing was marked when you left. How do you get back? One answer is that you don't need to consciously know. Your brain has been recording the whole time. Researchers studying spatial cognition have found that humans have a built-in ability called path integration. It works like dead reckoning on a ship. Your brain tracks the direction you've been moving, the approximate distance you've covered, and uses that information to build a running estimate of where you are relative to where you started. You're not aware it's happening. It's just running in the background, updating constantly, like a process you never open but can't turn off. But path integration breaks down over long distances. The errors compound. A small miscalculation early in a journey can put you kilometers off by the time you try to return. So early humans weren't relying on it alone. They were layering it with something else. Landmarks. Not landmarks the way we think of them now, with signs or labels. Landmarks in the pure sense. A specific hill, a river bend that curves at a particular angle, a rock formation that only looks a certain way from the west. Ancient humans catalogued these features the way a reader catalogues words, building an internal map out of accumulated observations. And that map wasn't stored in a notebook. It was stored in the brain, built up over years of moving through the same landscape, updated every time something changed. Here's what makes that more impressive than it sounds. It wasn't just memorizing a route, it was understanding space as a system. Researchers studying navigation in pre-literate cultures have found that experienced wayfinders don't just remember where things are, they understand how different places relate to each other, how distances feel under different conditions, how the same path looks different in different seasons or times of day. That's not memorization. That's modeling. And the capacity to build that kind of internal model is something humans appear to be uniquely good at, even compared to other highly intelligent animals. Then there's the sky. And this is where things get genuinely remarkable. The earliest recorded evidence of celestial navigation dates to around 3000 BCE, but the behavior is almost certainly much older. The basic idea is simple. The sun rises in the east, moves in a predictable arc, and sets in the west. If you're moving through unfamiliar terrain and you know where the sun is in the sky at a given time of day, you know your general direction. That's not a small thing. That's orientation. That's the difference between wandering and traveling. Ancient people figured out that the sky was a clock and a compass at the same time, and they built their entire understanding of space around it. At night, it gets more sophisticated. The North Star, Polaris, sits almost exactly above the Earth's rotational axis. It doesn't move across the sky the way other stars do. It just holds its position. For anyone in the Northern Hemisphere, it marks true north with a consistency nothing on the ground can match. Ancient navigators figured this out without telescopes, without formal astronomy, without anything except sustained, careful attention to what the sky was doing over long periods of time. They looked up, noticed that one star didn't behave like the others, and understood what that meant. That's a real insight, not a small one. The Phoenicians were doing this across the Mediterranean as early as 1000 BCE. They used Ursa Minor, the constellation containing Polaris, as their primary reference point. Greek sailors used Orion's belt. Different cultures, different stars, same underlying logic. You find a fixed point, you orient yourself to it, you move, and because the stars are the same stars every night in every location, that knowledge traveled with you wherever you went, which immediately makes it more powerful than any landmark. But no one took celestial navigation further than the Polynesians. And what they built is, by almost any measure, one of the most extraordinary cognitive achievements in human history. Starting around 3,000 years ago, Polynesian sailors began crossing the Pacific in outrigger canoes. Not along coastlines, not within sight of land, across open ocean in stretches that sometimes ran over 1,000 kilometers between any two islands. And they found their destinations. Repeatedly, accurately enough to build civilizations on islands so small and so distant that locating them without instruments seems almost impossible. They didn't use a physical compass, they used a mental one. Master navigators memorized the rising and setting positions of over 150 stars throughout the year, building an internal map of the sky so detailed they could determine their latitude at any point in the journey by measuring stellar elevation with their fingers held against the horizon. They knew which stars rose directly above which islands. They memorized those latitudes and used a technique called sailing down the latitude, essentially holding a fixed east-west position defined by a particular star until the destination island appeared. The skill took years to learn and was transmitted entirely through oral tradition, often encoded in song because nothing was written down. And it wasn't just the stars. Polynesian navigators read the ocean itself. Swells in the Pacific move in consistent patterns based on prevailing winds and geography. When those swells encounter an island, they refract, bending around it in ways that can be detected in the water long before any land is visible on the horizon. An experienced navigator lying on the floor of a canoe could feel those refraction patterns through the hull. They could sense an island they couldn't see. Some navigators describe being able to detect the presence of land from well over 50 kilometers away, purely from changes in the ocean's motion. They also watched birds. Certain seabirds travel toward land at dawn and away from it at dusk. The direction they flew in the early morning told a navigator which way to point. The species of bird mattered too. Different birds ranged at different distances from land. Spotting a particular type meant you were within a certain radius of an island, even if you had no other confirmation. It was a system built from layered observations, each one adding information, each one narrowing the uncertainty. Back on land, ancient travelers used a different set of tools, but the same underlying logic. Rivers were highways. They ran in predictable directions, connected known locations, and could be followed reliably even in unfamiliar territory. Mountain ranges served as walls and borders, giving travelers a sense of position even from a great distance. In places where the landscape was more uniform, like open grasslands or deserts, people used the wind. Prevailing winds in many regions blow consistently from one direction. Experienced travelers knew which way they were facing from the way the wind hit their face. And all of this was passed down. Not in books, not in maps, not in any written form. Through demonstration, through apprenticeship, through generations of people walking the same routes together until the younger ones had absorbed enough to walk them alone. Archaeological evidence from burial sites and ancient structures suggests that cardinal directions were understood across many cultures, thousands of years before any formal astronomy was recorded. The knowledge was already old before anyone thought to write it down. The routes existed before the maps did, carried in human memory and transmitted from one generation to the next through every technique people had for keeping knowledge alive.